Hello everyone, welcome once again to Geo-Spatial tutorial. I keep receiving mail from people asking me to explain the procedures involved in the generation of a digital elevation model or a digital terrain model using stereo pair images. Free digital elevation models what you get from NASA or ISRO website will have spatial resolution of close to 30 meters or 60 meters, but you may be in need of having a higher resolution digital elevation model for your work, for which you will have to have high resolution stereo pair images, and stereo pair images are not available free of cost, which you may have to buy online from some of the service providers. In this example I will be using Cartosat DEM, Cartosat stereo pair images, which is provided by ISRO. Let's open as Imagine. We will be creating digital elevation model using stereo pair images in Imagine Photogrammetry. First of all, let's open and see what is a digital stereo pair image. Stereo pair images are two images with the 20% side lap and 60% overlap. These are two images. Let me just open it in as Imagine. Let's zoom it to full extent, fit to frame, and these are the Cartosat stereo pair images. Right click, you have an option called swipe. Click on that just to see how do they overlap. You can very clearly observe that the features do not overlap. Say for example, this feature what you are looking at is here in the other image. That is primarily because of the 60% overlap. 60% overlap can be seen very clearly that this image from here till here is overlapping on the other image, and 20% side lap can be clearly seen here. Here this image ends. So these are stereo pair images. Using these images we will be generating a digital elevation model. Here you have a menu called toolbox. Click on that and click on Imagine Photogrammetry. It is a separate module. Just wait for it to load, it takes some time. This is your Imagine Photogrammetry project manager. Maximize that and let's go to File and click on New. Here you will be required to create a block file. Let's create block file in the same folder where we have the images. I'll name it as DEM and click OK. This will ask some of the parameters of your image. Here you have a lot of options depending on the sensor. Cartosat comes under rational functions. As I have already told you, we will be using Cartosat 1 stereo pair images. Here you have Cartosat RPC. RPC stands for Rational Polynomial Coefficient. Click OK. And you can change the projection. I keep it as it is, geographic latitude longitude, datum as WGS084, and click OK. This has created your block file. However, I advise you to go through the theory of photogrammetry to understand what is the concept of block file or vertical exaggeration, etc., etc. Vertical exaggeration is the primary concept behind photogrammetry, where you use the overlapped images, that is stereo pair images, to have a digital elevation model or a digital terrain model. Now that you have created block file, we have to add frames, that is add images. You can go to edit and add frame, or you directly have the option here to add frame. Let's open both the images that we have to add. select that, and these are the two stereo pair images, and click OK. Here is your process table. Here you have some columns with green and some with red. So your process is to make all these red into green to generate digital terrain model. Generally your pyramid layer also will not be calculated. This also will be red most of the cases where you will be required to calculate pyramid layers as well. Here, to calculate pyramid layers, click edit and click on compute pyramid layers, and if you click all images without pyramids, it will calculate pyramids for all the images in your screen which do not have pyramids. As in this case it is already calculated, we'll keep it as it is and click cancel. Now here you have interior and exterior orientation. Interior and exterior orientations are the satellite parameters from which your stereo pair images have been acquired, and these are given along with your stereo pair images. Now you can directly double click on this red button and it will ask you for Cartosat RPC. Just open your file. By default it is selected the correct RPC, but however you can just select it and click OK. This is your RPC and click OK. Your image frame is displayed here and your interior and exterior orientation for band A image has become green. Now let's go ahead with band F. Double click and select the proper RPC for band F and click OK, and click OK here as well. Your both the images have been displayed here and your interior and exterior orientations have been turned into green. Let's save it so that the process till now is saved. Now you can just click on edit and see you have done add frame. Frame editor is just the window. Compute pyramid layers have been done and your all other processes have been done till here. These are not processes, it's just properties. Auto type point generation properties. Same button you have over here, type point generation. To create a digital elevation model, you need to tie these two stereo pair images for which automatically points are generated. When you click this button, Imagine Photogrammetry runs an algorithm to select these automatic tie points, which are very important for the process. Just click on that. Your auto tie summary is displayed. Your band A and band F images and number of intended type points are 25 each and found are 28. 28 points were found and number of patterns found were 25. Point success rate is 100. Even if you see it to be somewhere around 70 to 80, you can accept it. For various sensor errors, if it is only 70%, you can accept it. Pattern success rate is 72, which is quite good for us. Let's accept that and click close. So your automatic type point generation is over. Now you have to carry out something called aerial triangulation. What is aerial triangulation? Again, I advise you to go through the theory because this is definitely beyond the scope of this particular tutorial to explain the theory behind triangulation or vertical exaggeration, etc., etc. Let's click triangulation and take default block triangulation and click OK. Here it says the RMS error is 0.09 pixels, that's close to 0.1 pixel, which is quite good. Let's accept that. Now your automated type points have being displayed on your images. These are the points where these two images are tied to each other. Let's go to file and save the work till now. Now let us go to process and go to DTM Extraction and click classic ATE, or you have the same process here in Z. Z is definitely the third dimension, so this is also DTM Extraction. Click on that and let's leave it as classic ATE and click OK. This process takes quite a long time, and let's define the output file. Let me define, let's consider output file as DTM band A and band F, and click OK. And here you can define the spatial resolution of the digital terrain model. By default it has taken 27.7, which is approximately 30 meters. That's what you get in a free digital elevation model, but you can enhance it. This is cell size, means to say in one cell how much ground is covered. So this particular Cartosat stereo pair images have a spatial resolution of 2.5 meters, and the thumb rule says that the best DTM that you can get is 3 times the spatial resolution of the stereo pair image. So in this case it will be 3 into 2.5, that is 7.5, close to 8 meters. That is 8 meters what you get here, but however it is advisable to consider 4 times, so I will put it as 10. So 10 meter will be the spatial resolution of this particular DEM that you are going to create. You can consider all others as it is, need not change anything, and click run. This will start extracting your digital terrain model. This takes a good 15 to 20 minutes to carry out this process. In between you might even feel that your computer is stuck, primarily because it's a heavy process that takes good amount of time. So please have patience, wait for 15-20 minutes for the process to complete. I'll be cutting short my tutorial, unless we'll be just pausing the tutorial at present, and we'll resume once the process is over. There you go, your process is complete, and your digital elevation model or digital terrain model is ready. But however, you have an option to edit your terrain, which is called digital terrain model editing. Click on that. It will open a totally new window, and you save the changes whatever you have made till now. And this is your terrain editor. But however, for you to edit terrain, you need to have ortho images as well, not only stereo pair images and the digital elevation model. So let's close it and create ortho images. Clicking on this one will create ortho images. Let's consider the default value and specify an output directory. And let me consider it as ortho band A and click OK. And this will again take some time for you to process the ortho images. Let's wait. There you go, your band A ortho image is created. Let's create band F ortho image and accept all the default values and click OK. This process again takes some time. Let's wait for that. Now your band F ortho image is also created. Click OK. Your all the processes are over. Now let us go to terrain editing. Let's save the file and open terrain editing. This is your terrain editing as I have told you, and let's maximize that and right click here and add to all views. Your DEM editing starts now. As you can see here, this is a cyan and red combination. So to do DEM editing, what you need is a cyan and red 3D glass, without which you will not be able to do DEM editing. But however, I'll just explain this window, whereas I may not be able to explain you how to carry out the editing, because it requires you to have a 3D image and an expert sitting next to you. So I either advise you to go through the manual and carry out the entire process, or just take advice from some expert in editing the DEM. Here is your DEM editing window. Here you can change it as you want. It is in stereo now. You can go for try view, and this is your terrain files and display, and this is the digital terrain model that you have just created and load it. That will load the digital terrain model onto your image in the editing mode. So as you can see, a lot of points have been added. You can also add these values. You can see here some lines are there. Now let's go to the actual terrain editing. This is only for display purpose. Once you go to the terrain editing, here there are select options. Now you take your cursor over the window. You can see these lines actually changing. If you see the green line that is moving, is only a basic, but you have advanced methods to edit your digital elevation or digital terrain model. Let's go down. What other options do we have here is export. You can just click here. You can export your contours to a file. Let's give the export contour file as shape file and click save. Your file is saved, but let me tell you, it has saved only the contours within this screen. So if you want the contour of the entire set, entire image, you have to zoom to full extent and then carry out the process of saving your contour map. So let us see whatever we have saved, how does it come. Let's just open the contour that we have just saved and see whether it is correct. There you go. Here is the contour that you have just saved. Click OK. You can see your contour over here. You can zoom out your map or image here to the full extent and get the contour map of the entire area. Next, your image adjustments is only to adjust your image brightness and move cursor. How do you want it to move? And view manager, it is to view your image. You have options here like device. You may have 3D mouse. There is a 3D mouse to edit them. Generally it is used in professional or commercial organizations. Here what we will be using is only the mouse. And cursor mode is, you can see the options, and similarly you have all other options. You can try DEM editing on your own, terrain editing. You can edit the terrain. As you can see here, the options are available. This is terrain editing, and I'll not explain it. Hopefully, I will try to explain it in some other tutorial. Here, I just want to tell you that if you find that this particular elevation line is not matching with the base, then using your 3D glass and your mouse, you can redefine in the place where you feel the line should actually be. Now let us open the digital terrain model that we have just created. Open it, and this is the model that we have created. Click OK. That will load your DTM. You can just do a right click and fit to frame to view it to its fullest extent. And this is the DTM that we have created using the stereo images, and you can use it for any purpose you want, like arc hydro tools or any hydrological purposes in any software. You can now use the same DTM in your ArcGIS as well. Now if you zoom it to the pixel level and measure individual pixel, that will be 10 meters. That means to say that the spatial resolution of this DTM is 10 meters. That's all about creating DEM or DTM using stereo images. Thanks for watching.